Okay, so the first special triangle that we're going to focus on is when the angles of the triangle are the 45, 45, and the 90 degrees. And that's exactly what we call it, the 45, 45, 90 triangle. So question 3 asks you, if the measure of angle C is 45 degrees, how can she determine the distance across the pond, or the length of AB? Well, remember, we have an isosceles right triangle, so we can measure on dry land the length of BC and know that AB is exactly the same thing. So BC tells me AB. So let's look at question 4. You're going to sketch a 45, 45, 90 triangle. You want angles A and B to be 45, which means angle C, using the triangle sum theorem, would have to be 90 degrees for all of those to add up to 180. Now let's list all the things that we know to be true. Well, since these angles are both 45 degrees, we know they're congruent to each other. And we know that the angle measures and the side measures have a relationship with one another. If we have two angle measures that are equal, we know that we have two side lengths that are also equal. So the sides across from those angles would also have to have the same length, so we call those congruent. And so we have the hypotenuse here that of course would have to be longer than these sides. Since that angle is bigger than 45, the side across from it has to be bigger than the side across from the 45 degree angle. So those are the things that we know. Since it's an isosceles triangle, remember we would have all those rules of isosceles. If you drew an altitude here from the vertex angle, it would be a median, an angle bisector, and a perpendicular bisector. We don't have to know all of that for what we're looking at right now. We just need to make sure we understand these angles are congruent, so these sides are congruent. And make sure we understand that this angle has to be 90 if both of these add up to be 90. And so we're going to look at a second animation here with the 45, 45, 90 triangle so that we can see a relationship that's going to be helpful for today. So we have the 45, 45, 90 triangle, and we know we can apply the Pythagorean theorem since this is a right triangle. So using the Pythagorean theorem, we know that a squared plus b squared, the square of the legs, has to equal c squared. But since this is isosceles, both of these sides are the same length. So instead of calling them A and B, I can call them both A's. So I know that kind of went a little fast there. Let's start it over and make sure we see what's going on there. So we start off with a squared plus b squared equals c squared. The legs squared added together has to give me the hypotenuse squared. But since these are the same measure, we know the sides are the same measure. So they're replacing one of those, the b, with an a. And so that's all that's happening there. And so we can say instead of a squared plus b squared, that we have a squared plus a squared. Now I can simplify that. We're going to put numbers in for a here. So they're replacing the a's with 1. They've just chosen a number to substitute those with. And this is just going to show us that we can now find what c squared is if we know these sides are 1. We could simplify this side. We know that 1 squared plus 1 squared is, of course, 1 plus 1, which is 2. And we can undo the squaring of c by taking the square root. And so we get a relationship that was going to be really handy for us for this 45, 45, 90 triangle. We know if the legs are 1, then the hypotenuse is the square root of 2. And we're going to use this as what we're going to call our reference triangle. So our reference triangle is when the sides, the legs, are going to be 1, and the hypotenuse is the square root of 2. Okay? In other words, we know that the legs have to be the same number. Whatever this one is as well. And to find the hypotenuse, I'm going to multiply whatever that number is by the square root of 2. So if instead of 1s, if I made these 3s, then this wouldn't be the square root of 2 anymore. It would be 3 square root of 2. Whatever number is the legs would be in front of the square root of 2. And that's multiplication between the 3 and the square root of 2. So that answers question 5 in your notes. You're going to draw your reference triangle, and that's when the sides are 1, the legs are 1, and the hypotenuse is the square root of 2.